All right, welcome to Business Math. It happens to be January 27th. Today we're going to take a look at some more fractions. And hopefully this is Ponca City joining us.
Yes, it is.
One of the things that I want to remind you about is the books so far that I have mentioned in class. These are the books that you will be able to read for extra credit. All you have to do, and this is for you live students or you online students, and so how to solve it was the first one. The second one was 7 Habits of Highly Effective People. And these are all awesome books, by the way. Later on in the course, we're going to do some statistics. So how to lie with statistics. And how to get ideas is a new one that I just finished. It's an awesome book for getting ideas for problem solving. And then the last one I mentioned, this is after a massive failure. This is by John Maxwell, Failing Forward, which good problem solvers always fail forward. That means they learn from their failures. They don't ignore them. They actually study. In fact, very successful people spend more time studying their failures than they do studying their successes. So that's the reason Failing Forward is on that list. And I will be adding to that list as time goes on. So today we're going to talk about fractions. Oh, these books, all of those are available in audio, except I'm not sure about how to lie with statistics. Not sure about that one, because that one I've just had in a hard copy. I haven't looked for it, so I don't know. It may or may not be available in audio. But I'm totally addicted to audiobooks, so it's just an absolute time saver. All right. First of all, let me give you a chance to ask a couple questions so far on Chapter 2. That's the one that we're in. It's on fractions. Last time we did talk about adding and subtracting fractions a little bit. That's what it was. And hopefully you're finding this pretty easy. I'm going to save this so I don't have to do that again. All right. So let's see how much you remember about adding and subtracting fractions. When we take a couple of fractions to add, let's go back really simple, because that is one of our problem-solving strategies, isn't it? Make the problem simpler. Okay? So we're going to analyze the method here. When we take a half or a third plus a half, what's your first step in taking a third plus a half, Rachel? You're going to add a third plus a half. How do you do that?
Sorry. You have to get the denominators the same.
Yep.
You have to find out which number.
Very good. Yeah. And the reason for that is because, see, what we've got going on here is what we have a third of a pizza, plus we're trying to add to that a half of a pizza. You can't add a third of a pizza to a half of a pizza unless you get the pizza sizes the same size. So that's the reason for finding the common denominator. So the common denominator actually says, hey, let's get all these pieces the same size. So when you're getting the least common denominator of these two, that's what's going on. That's the concept. Very important for you to know the concept. It's not magic. It's just that we're getting the pieces of pizza the same size. And so consequently, in this case, well, 2 and 3 are both prime numbers. By the way, what's that mean, a prime number, Courtney?
It's only divisible by itself in 1.
Very good. Only divisible by itself in 1. So in this case, the common denominator is pretty easy because we need a 3, we need a 2, and so 3 times 2 equals 6, so that's the common denominator. So we know that both of these are going to be over 6. So then we have to figure out what can we multiply numerator and denominator there by, because we're really multiplying by 1, so we're not changing the value, 2 over 2. So that changes into 2, 6. Here we're multiplying numerator and denominator by a 3, and that changes into 3, 6. And 2, 6 plus 3, 6 is how much, Robert?
5, 6.
5, 6. So that's the answer, 5, 6. And 5, 6, is that, can that be reduced down any further, Jonte?
No, sir.
Nope, it cannot. Very good. So that's it. There's the answer. Now, when you have problems that involve more difficult, by the way, the same thing is true for subtraction, isn't it? So in fact, if we were to change this to a subtraction problem, let me see if I can grab the eraser here. And let's go ahead and grab this eraser and change this. Whoops, daisies. Grab the eraser. All right. And change this to a subtraction problem. In that case, and then let's go ahead and erase this here. Let's see, I'm having trouble. I didn't want to do that. Control Z. Oh, I guess I can do that. Oh, I wanted to undo that, didn't I? Huh? Well, anyway, I'll just put it back. Minus, this was 3, 6, wasn't it? This was 2, 6 minus 3, 6. Okay. 2, 6 minus 3, 6. And so we'd end up with a negative number, right? In fact, Jonte, what would we get?
We would get negative, not negative, but...
Yeah, we would. We'd get negative. That is correct. Because 2, 6 minus 3, 6, you'd get a negative...
Negative 1, 6.
Very good. Negative 1, 6. That's it. Okay? So, but the same thing applies. Now, when you're doing multiplication, it is not necessary to get common denominator because we're not adding. When we're multiplying, we just take the numerator times numerator, denominator times denominator, and we get 1/6. So what's going on visually here is if you take a third of a piece of pizza and multiply it by a half, cut it right in half, you'll end up with a sixth of a piece of pizza. That's the reason why, by the way, why we just take numerator times numerator, denominator times denominator. Okay? So that's the adding and subtracting fractions. We talked a little bit about that before. You're going to be doing more of this in your homework problems in section 2-3. So, let's do some really hard fractions and see if you can get the common denominator. Let's just pick something very, very difficult. Oh, let's pick something like this. 3 over 121 plus 4 over 93 plus 5 over 36. Okay? To add these three fractions, we're going to need to get the common denominator. Well, what you're going to need to do is, you're going to need to do factor trees on each one of these. In other words, you're going to have to factor 121. Let's go through some of our rules about if it's divisible by, let's start with 2. Is 121 divisible by 2? Let's go to Rachel. What do you think?
No, because it would give you
No.
a decimal.
Yeah, gives you a decimal number. In other words, the rule for divisibility by 2 is just whether it's an even number or not. So, in this case, the 1 is an odd number. So you know it can't be divisible by 2. Now, does anybody remember the divisibility by 3 rule? Oh, let's see, Courtney, do you remember? I mean, you can just grab your handy-dandy calculator and take 121 divided by 3, but there is a technique, and if you forgot it, don't worry about it, but I was curious if you remember.
No.
Does anybody else remember?
C would go into 100.
By the way, Courtney, I didn't give you a 0.
Okay.
Okay, let's see, John Tay, did you say that you remembered how you tell if it's divisible by 3?
C would goes into.
Well, that's a good answer. I like the answer. In other words, you can just go ahead and try 121 divided by 3 on your calculator, and you get 40.33333, so you know it's not divisible by 3. But here's the technique. If you add up the digits, 1 plus 2 plus 1, if that number is divisible by 3, then you know 121 is divisible by 3. Well, 4 is not divisible by 3, so therefore 121 is not divisible by 3. Okay? By the way, see what we're doing is we're checking the prime numbers. 2, 3. What's the next prime number, Robert?
5.
5. What's the next prime number, Jonte?
7.
7. What's the next prime number, Courtney?
9.
Oh, is 9 a prime number, Courtney?
11.
Oh, there you go. 11. See, that's why on Millionaire they always go, set your final answer. Let's see, Rachel, what's the next prime number?
$15?
15 is a good... Oh, go ahead again.
No, that's okay. I said 15, but it's probably not right. But
Well, 15
that's what I
is
said.
3 times 5, so you know 15 is not prime.
Okay.
Well, let's take them one at a time. Is 12 prime, Rachel?
No. Oh.
No.
No. No, it's not. And Jonte, why is 12 not prime?
Because you can divide other numbers into it.
Yeah, 3 times 4, 2 times 6. So 12's not prime. Is 13 prime, Rachel?
Yes.
Yes, it is. So, and you keep going. I think the next prime, let's see, 14's not prime, 15's not prime, 16's not prime, 17's prime, 18's not prime, 19 is prime, 20's not, 21's not, 22's not, 23 is, and you can keep on going, right? Well, anyway. So, now, divisibility rule by 2 is if it ends in an even number. So it's not divisible by 2. Divisibility by 3 rule, if you add up the digits, that should be divisible by 3. It's not divisible by 3. Now, let's see. Courtney, do you remember the divisibility rule by 5?
Anything that ends in 0 or 5.
Very good. If it ends in a 0 or a 5. So, Rachel, is 121 divisible by 5?
No.
No, it is not, because it does not end in a 0 or a 5. So, let's see, we got to go to 7. Now it's starting to get hard. So now you might have to grab your calculator, and you might have to start trying. 121 divided by 7. I would bring your calculator to class every day. Go ahead and bring your calculator every day. Okay, is 121 divisible by 7? Courtney?
No.
No. Is 121 divisible by 11? Jonte?
Yes.
Yes, it is. And in fact, 121 is 11 times what, Robert?
11.
Yep, 11 times 11. So, we have that one finished as a product of primes. All right, let's see if we can do 93. Is 93 divisible by 2, Jonte?
No.
No, it is not. Is it divisible by 3, Courtney?
Yes.
Yes, it is. See, 9 plus 3 is 12, so it is divisible by 3. So I think the answer is 31. Did I do that right, Rachel?
Yes.
Okay. Oh, now this is a tough one. Is 31 prime? What do you think, Jonte?
It is.
I think it is. I think you're right. That is prime. So we're done with the 93. All right, 36. Is that divisible by 2, Courtney?
Yes.
Yes, it is. So we know we've got 2 times 18. Now we'll keep on a roll, and let me erase some of this stuff to give me more room. Let's see. Is 18 prime? Let's go to Rachel.
No.
No, it's not. So that means we can break down, we can take 18. By the way, is 18 divisible by 2, Courtney?
Yes.
Yes, it is. So we go 2 times 9. Is 9 prime, Robert?
No.
No, it's not. So let's see. Is 9 divisible by 3? Courtney?
Yes.
Oh, Courtney, is 9 divisible by 3?
Yes.
Yes, it is. So 3 times 3. So we're done with 36. So 36 is a product of primes. It is 2 times 2 times 3 times 3. So now we're ready to get the least common denominator. The least common denominator. We need an 11. We need another 11. It's going to be 11 squared. 11 squared times, we need a 3. Don't have a 3 yet. Need a 31. Don't have a 31 yet. Let's see. Oh, we need 2 factors of 2, don't we? We need 2 factors of 2. We already have 1 3, so I don't need to write 3 down again because we already have it right there. But I need an additional 3, so I need a 3 squared. So in this problem, it's 11 squared times 3 squared times 31 times 2 squared. Well, let's see. I used to be good at math. 121 times 9 times 31 times 4. I have a 100. I told you it was going to be nasty, didn't I? I have 135,036. Anybody else double check me on that? Did I do that right, Rachel?
Yes, that's right.
All right, thank you. Now, I don't know if we're going to take time to finish this problem, but just to tell you how to finish it, to get the number that we're going to multiply numerator and denominator by here, you have to take that 135,036 and divide by what, Courtney?
The numerator.
Well, you're close. The denominator. You got to divide it by 121. You got to take 135,036 divided by 121 to get the number to multiply numerator and denominator by. Okay? Because that will turn it into 135,036. So in other words, if you take that 135, now if you have memory in your calculator, you probably want to put that 135,036 in memory someplace. Then you don't have to type it in every time. But if you divide that by 121, then you get 1,116. So that's the number that's going to be multiplied numerator and denominator by. How are you going to find out what to multiply numerator and denominator by on the second fraction? Courtney, go ahead and give it another try.
The denominator.
Yes, so now take the 135,036 and divide it by 93, and you get 1,452. And if you enjoy this, you're weirder than me. That's pretty weird, isn't it, Rachel?
No, you're not weird.
Ah, extra credit for Rachel, 8,000 points. All right. Now to get the next one, we take the 135,036 divided by what number, Rachel?
36.
36. So now you understand why most people like decimals better than fractions. Because, look at this mess. We're not even going to finish the problem. You have to take 3 times 1,116 plus 4 times 1,452 plus 5 times 3,751. Add those all together. Put it over 135,036. And then you got to look to see if that is in lowest common denominator form. So, now you know why people like decimals. Because if we were just going to do this to get a nice, quick answer with decimals, let me erase all the yuck. Whoops, can't go too nuts here. Let's erase that, erase this, erase that, erase this. Erase almost all of it. I gotta have to rewrite my 121 in there again. I'll put the 121 back. If you were going to get the decimal equivalent of this on a calculator, now this next part that I'm going to tell you is very important. On your calculator, which I think most of you have a calculator, don't forget to bring a calculator to class, okay? And the reason this is so important is because you're going to get really good with your calculator, and then when you do take you're going to have your midterm exam and your final exam, I'm going to let you use a calculator, so you're going to hopefully get really good at your calculator. Now this next step is really, really important, and I'm going to have you learn about your calculator that you have right now. I draw a big red line there, and now on this I want you to punch into your calculator. 2 plus 3 times 4 equals, and then on your calculator, you got to tell me your answer. So I'm going to do it on my calculator. 2 plus 3 times 4 equals. Now, there are 2 possible answers depending on the type of calculator you have. If you have a Kmart Blue Light Special, or if you have a calculator that you got for free from your insurance agent or something like that, some calculators will give the answer of 20 because it'll go 2 plus 3, and that is 5, and then it'll take that times 4, and then it'll get 20. Now some calculators are going to give you 14, because even though you punch in 2 plus 3 first, then times 4, it's going to multiply the 3 times the 4 first, get 12, then it's going to add it to the 2 to give you an answer of 14. Now one of those is actually the right answer, and one of them is the wrong answer. All right, well, let's do this by vote. Raise your hand if you think the correct answer is 14. Let's do that first. All right, now raise your hand if the correct answer is 20. Now raise your hand if you want to go home and go to bed. I have my hand raised. All right, this 8 o'clock stuff, this is pretty early, isn't it? And by the way, it's harder on you all than it is on me. Because it's hard to fall asleep talking. I think I've done it before, but anyway. Well, the correct answer is 14. So those of you that raised your hand 14, that is right. It is not 20. If you have a Kmart Blue Light Special, it'll probably give you the answer of 20. That is because this is called order of operations. Order of operations. And there's a mathematical order of operations. it turns out you don't even need parentheses around the 3 times the 4. That has a higher precedence than addition. So that is extremely important to know, that multiplication has a higher precedence than addition. Now let's go over that order of operations very quickly, because it is so important. Then we're going to come back and finish that problem up there with a decimal. All right, here's the order of operations. Pretty please, my dear Aunt Sally, or if you like this, pepperoni pizza makes Dad awfully sick. All right? Either one of those, doesn't matter. All right? So, the order of operations, this P right in here stands for parentheses. It takes precedence over everything. Parentheses takes precedence over everything. So this is parentheses. Parentheses. That takes precedence over everything. When you have parentheses going on, it doesn't matter what else is there, you can override order of operations with parentheses. The next one stands for powers. So if you have any exponents, those are going to go next. Okay? Any powers that you raise to a power, second power, third power, fourth power, whatever it is. There really probably should be parentheses around the multiply and divide, because these two actually are in the order of left to right. This is M and D are multiply or divide, and that is in order of their symbols. That's in order of their symbols. So sometimes you will do the division before the multiplication. Okay? So if you have 12 divided by 4 times 2, this division will take place before the multiplication. So you will take 12 divided by 4, which is how much, Courtney?
3.
3. And then you'll take the 3 times the 2 and get 6, okay? So this multiplication or division, that's in order from left to right. And then you'll do your addition or subtraction in order of left to right. So in other words, what's going to happen is sometimes subtraction may actually happen before addition. So if you have something like this, if you have 8 minus 3 plus 2, then the subtraction is going to happen before the addition. Now the reason that it is so important to know on your calculator, on that original problem that I gave you, of 14 or 20, the reason that that's so important that you know on your calculator, the reason that's so important is then you'll know if your calculator has correct order of operations. Because if your calculator does not have correct order of operations, I would get another calculator, okay? A lot of times, just your handy dandy calculator like this, I was a little bit surprised that this calculator gave me 14 on my phone. I was a little surprised. Now, I wouldn't be surprised, see, when I turn it like that, I get a scientific calculator. I wouldn't be surprised if I got 14 on my scientific calculator, because every calculator that I've ever seen in my life that is a scientific calculator has correct algebraic order of operations. But your little handy-dandy calculators like this, most of these have incorrect order of operations. So, did your calculator give you 14, Rachel?
Yes.
Yes, that's good news, isn't it?
Yes,
Let's
it
see.
is.
And so the rest of you, I think, let's see, John T., you don't have your calculator with you, do you? So bring your calculator to class, every class, because that way you get really good at using your calculator. Now, the reason that I had you check your order of operations, if you have correct order of operations, this problem up here on the top half of the page is very simple to calculate using decimal equivalents. Because the line in a fraction, what's that line in the fraction mean, Robert?
Divide.
Divide. So all you have to do, if your calculator has correct order of operations, is punch it in just like this. Let me erase this down here. Okay. So if your calculator has correct order of operations, all you have to do is type in 3 divided by 121 plus 4 divided by 93 plus 5 divided by 36 equals, and you'll have the decimal equivalent of the correct answer. Now, that's pretty dang cool, isn't it? And you don't even need to put in these parentheses that I'm putting in red. These are totally unnecessary. All right. So on your handy-dandy calculator, let's see. Some of you probably already have it done. 3 divided by 121 plus 4 divided by 93 plus 5 divided by 36. Rachel, what'd you get? Oh, you'll have to press your, open your mic.
0.20669,303, or
Yeah.
0.21.
Yeah, you gotta, it's a big long decimal, isn't it?
Yeah.
Now, in real life, if we were doing this as, let's say, these were all probabilities, and we were adding the probabilities all up, most of the time, you know, depending on the application of how many significant digits, you probably don't need all those digits. In real life, and in fact, if you wanted to change this into a percent, in real life, 20.67% would be plenty good enough, wouldn't it? See, in real life, if we just took 4 digits. By the way, why did I make that into a 7 right there? Why did I make that into a 7, Jonte?
Because the 2 6s right there, you have to round up.
Yeah, because this was a 9, wasn't it? See, and I had to round that 6 up to a 7. All right? That's some really good information for you to know how to do that, how to do fractions on a calculator. Because in real life, and all of the real life things that I've done, I don't add fractions very often at all. Okay? I almost always deal in decimals. And even the stock market now, we've switched to decimals in the stock market, so I don't use fractions hardly ever. Now, I use the concepts of fractions a lot. I use the concept and the concept of ratios. The concept of ratios are very, very important, which ratios, by the way, are fractions. So the concept of fractions is very, very important. Well, then your author goes over the multiplication of fractions. Multiplication of fractions is even easier than addition, isn't it? So you could take, I don't want to clear the ink on that yet. Let me not do that. I'm going to erase and change all of these to time signs. Now, what's so beautiful about this is you don't need common denominators, do you? Wow. This turns out to be a pretty easy problem, actually, because all you got to do is take 3 times 4 times 5 and put it over 121 times 93 times 36. And there's your answer. And then you're supposed to reduce it down and all that good stuff. But multiplication is pretty easy, isn't it? Now, if we had division, let's change that to a divide right there. We're going to change this to a division sign right there. The thing to remember when you have division, now the multiplication part is right there. By the way, back to the multiplication just for a second, okay? I have found out by experience that it's easier. I want to talk a little bit more about multiplication before I move on to division, okay? Let's erase this out here. I have found out by experience. Go ahead. I'm sorry, Rachel.
I can't see what
Oh,
you're doing.
Thank you. And see, Rachel gets extra credit for helping the old man out there. Thank you, Rachel. So,
You're welcome.
I have found out by experience that rather than just taking the 3 times, oh, I had the eraser on, didn't I? That wasn't good. Rather than just taking the 3 times 4 times 5, and the 121 times 93 times 36, I try to make some simplifications here first. I try to combine and divide the numerator and denominator by the same thing. So, for example, I can divide 3 into there, that goes once. I divide 3 into there, that goes 31 times. The reason I can do that is because actually I'm taking 3 over 3, which is equal to 1. That's the reason I can divide this by 3 and divide this by 3. Now, you remember way a long time ago, I said that this word right here was a dirty word. We don't say that word in my class. Because it implies magic. Cancel, I don't like that word, all right? So we divide numerator and denominator by the same thing. So I divide numerator and denominator by a 3. Now I can divide numerator here by a 4, divide that by a 4. You see, it does make it a lot simpler. Because now 1 times 1 times 5 is 5. 121 times 31 times 9 is a very big number, but at least you don't have to worry about simplifying that when you're all done. All right? So, that's very important. Muy importante. Now, let's do the division problem. Let's say we have 3 over 121 times, well, let's make it real nasty. Really nasty. Divided by 4 over 93, divided by 5 over 36. Well, if you don't like division of fractions, which I definitely don't like, now what you do is just change it into a multiplication problem. Now the reason that we can do this is because multiplication is an inverse operation of division, meaning you can multiply by a half or you can divide by 2. Those are the same thing. It's a reciprocal or a multiplicative inverse operation. All right. Now, lastly, your author does some adding and subtracting of mixed numbers. Adding and subtracting of mixed numbers. This is always fun, isn't it? So adding and subtracting, let's do a couple simple additions. 2 1/4 plus 3 3/4. All right. Well, you don't even have to get common denominator because we already have common denominator, right? So 1/4 plus 3/4 is how much, Rachel?
4/4.
Very good. See,
4, yeah.
That's right, 4/4.
Yeah.
And then you go 2 plus 3 is 5. So we get our answer of 5 4/4. Well, that's not a good simplified answer. So you got to go 5 plus 1, and that makes 6. All right? So if you're doing this, you got to get common denominator, and you may end up with an improper fraction like I did right there, 4 over 4. So then you got to go ahead and convert that. Now, let's do some subtraction here. All right, and we're about out of time. And I promise you the time went way faster for me than it did for you. It's very painful to sit there as a student because the time goes about 3 times as fast when you're teaching here. Well, now, 12 1/4 minus 3 3/4. The first thing I got to do is I got to borrow a whole number from here, and I got to add 4/4 onto 1/4 to get my 5/4. Now I can subtract 5/4 minus 3/4. So that's 2/4. 11 minus 3 is 8. 8 2/4. And then you simplify that to 8 1/2. So you're going to have some of those problems as well. Then you're going to have multiplication of mixed numbers and division of mixed numbers. You're going to have that. So we got about 2 minutes left. And let's see, if you were going to multiply, oh, let's take something not too terribly nasty. 3 2/3 times 5 and 5/8. The first thing you got to do is change both of these to improper fractions. 3 times 3 is 9, plus 2 is 11, so you got 11/3 times, there's 40, plus 5 is 45/8. And now you're ready to multiply. Okay? Now again, this little trick is handy because there is a 3 sitting there in 45, I believe, because 4 plus 5 is 9. So I can divide numerator and denominator here by a 3, so I get a 15 here. Now to get the answer, take 11 times 15. Now, back in the old days, we learned all these little tricks. When you multiply by 11, you write the 1 down, you write the 5 down, you go 1 plus 5, put that in the middle. Isn't that a cool trick for multiplying by 11? We don't really teach that much anymore. Anyway, 1 times 8 is 8. Now change that into a mixed number. If you're doing division, let's pretend this was a division problem. If that's a division problem, it's almost the same, isn't it? Almost the same. If that's a division problem, I should get rid of this, change that back to a 3, change this back to a 45. All right, change that back to 3, back to 45. Now what we need to do is, it's invert and multiply, don't we? So we got 11/3 times 8/45. Bada bing, bada boom, finish that, you're done. Well, you guys did great today. Absolutely fantastic. So, assignment is page 51, the practice quiz, and page 53 is the extra practice quiz. Alrighty. You guys did great. Have a great day.
Dr. G,
Sure.
I didn't